These are just some random goodies I got today. These are a pair of transformers for some homemade inverter things that I'm going to be working on. It's my standard transformer drive inverter design. 18 volt or 18 and a half volt 6 ampere center tap secondary. That's what I'm going to be using as the for the 12 volt side of the inverter. And a pair of 117 volt primaries, so this thing can be so I can make either a 120 volt or 240 volt inverter, or with a switch, a combination thereof. 15 bucks each, which is a pretty good price for transformers of this type. The closest thing I could find from DigiKey was a 5 ampere 18 volt center tap secondary, and those are close to 30 bucks a piece or something. These also have a 26.5 volt 100 milliampere rated secondary. So I don't know what I'm going to use that for, but maybe an auxiliary power supply or something. And another thing is that these are electrostatically shielded, which pretty much there's I think the internal constructions is there's just a an open copper or some other metal tape winding of one turn or so, and it's open, of course, so it doesn't short the transformer out. And that's just connected to a flying lead coming out of the transformer. So if you ever see a transformer with a white wire coming out of it, or I think they're usually white, all the ones I've seen are white for the shield, that doesn't seem to be connected to anything and isn't electrically connected to anything else in the transformer, that's a electrostatic shield. That's pretty much to prevent capacitive coupling of noise from the primary to the secondary. I also got a bunch of warning labels. Again, this is all simple sales in Nebraska stuff. Danger, high potential up to 2,000 volts exposed with cover removed. High current exposed at various points, probably won't guess what I've got those planned for, he said sarcastically. And of course, up to 70 volts may be exposed, blah blah blah. And up to 180 volts. Got those from my inverter thing and my charge controller design. I also got some of these lamps. They're 1251s. A dual filament, which is interesting. They're 590 milliampere 13.8 volt. I don't know whether or not those filaments are wired in series or in parallel. Focus. Thank you. Kind of reflecting. But that'd be interesting if those were wired in parallel, which they might be. That provides some degree of redundancy in the event of one filament burning out. Then I got these 5 volt, 115 milliampere grain of wheat lamps, also domestically made. Yay! On my camera. And another interesting thing, which one of the reasons why I'm posting this, is that they have 54 series military specification TTL chips, which are very hard to find nowadays. Not even DigiKey carries them, or James or any of the other big names. Those ones which aren't marked, those are 54 F32s, 54 192s, 54 30s. They also had a bunch of cheap house marked TTL chips. Those are 27M49. Don't know what those were, but they say what they are. I might put that in the annotation or not. 54 LS74s, 54 LS42s, 740C 138s. Those I just got because they were cheap. And 5411s, 5416s. What are those? Oh, those are on the house marked ones. Those are 08E. Was those 05E E13 or 18? I don't remember which. What else? And those are house marked, which also have the normal part number. Those are 71K09s, and they're 740 Random interesting stuff. Might be useful to some of you out there who's looking to get some 54 series TTL for projects or whatever. Although you have to check the prices, because some are very expensive, some are very good, and that tends to be the pattern with their prices. Some are absolutely inordinate, some are extremely cheap. And there was one other thing of interest that this is one last thing I got, largely as a curiosity, because I don't have a use for it at this time, but that's a flat pack chip, and those are used a lot in very high-spec military avionics type electronics, but they're a very rare, hard-to-find package, and that's because it's so specialized. I just got that large as a curiosity. It was cheap, it was only like $1.20, I think. So yeah. And of course some special, presumably electrostatic dissipative plastic. So yeah. And of course obviously hideously expensive new. So yeah. This is the inverter circuit I was talking about. It's just a ST3524 PWM driver, a couple of FETs, and the transformer. Simple and it works. Just 120 volts matched across the output, or 240 volts depending on what on the secondary in this, what was now the secondary of this particular transformer. And also, of course, getting the phasing right is important, otherwise it'll short out the transformer, which would be bad. And I just have a other terminal block just to keep the that's just cable management to keep the flying leads for the other secondary winding from shorting out.